Yes. Woo! Okay, so the timestamp is 8 o'clock. So new thing was produced. Okay, so here's one thing that I didn't really explain. So S3, why we like to use it for demo purposes, S3 gives you a free web server right on top of it. So that the images that you put into that bucket have a consistent and publicly accessible URL. Can I zoom in? Adam, how do I zoom in?
Control scroll.
Thank you.
Control plus.
I don't think it's going to work on that monitor, though.
Okay. All right, no, I don't know how to use a computer.
Control plus.
Control plus.
That does not work. Okay, this is a full. Anyway, so let's move on. So pretend that there is a file in that bucket. Okay. So S3 gives that functionality to you for free. If you're in a more secure, sensitive environment, don't use it. You can stand up your own web server, use Nginx, use Apache, use whatever you know. You can stand that up on an EC2 server or whatever it is that you want to use internally. Right? The same way that we map our local file system to that S3 bucket on your local machine, you can do that on your server. So now that I have a URL to that resource, I can begin to stage my dashboard. I can start to actually take those products and put them together into some sort of a presentable format. So for the purposes of the presentation, I went with Google Sites. It's not a good product, but it does what I want it to do, right? So what you see here is Zombies output. They've produced, I have no idea what they've produced, but I know how to link to it. So if I go into insert, image.
While he's doing this, it's age against total account balance, and then colored by employment status.
Awesome.
Fancy.
Okay, so maybe that's a good idea. As I try to include the team's component into the actual dashboard, the team can explain what it is that they did, that they've done, that they've did. Anyway, you got it, right? So here is this one.
Is it easy?
That does not work. Okay, anyway, so this URL is the URL to that S3 bucket. So s3.amazonaws.com, rwizflowy bucket, that's the name of the bucket, / your team name. Why? Because that's how we set it up. So if I go inside of Google Sites, what's the name of that team again?
Zombies.
Spell it.
ZONG-zombies.
It's tough. And it's called newthing.png. Boom, there it is. Got it? Like you're almost done. There's really not much more to do. So this is what you see here. I just embedded their output. Do we have another team that we want to add?
Yeah, charts.
Charts? Okay, so let's do this whole thing again.
Joe, can you talk a little bit about while we're getting it set up, what it is?
Yeah, so we took the existing scatter plot and we basically just swapped out the x-axis. So instead of age, it's by network. And the chart isn't very pretty. There's something like a categorical thing going on. But it's a reimagined view of that scatter plot.
What's the name of the output file?
It's scatter plot with LM example, the same as the scatter plot example.
Nope. Scatter plot. Aha! Quick feedback loop. I made a mistake. There you go. There it is. So I'm just going to save it. That's enough. And that's enough. That's it. It's saved. So, of course, now when I refresh this, you're just going to get the same image over and over. Right? So we've now completed both the authoring process and some form of staging, at least the authoring portion of the staging process.
Okay, so we didn't have time to go through the whole Git process where The people that made wrote their R scripts to output these will submit a pull request in, and we'll review those and actually merge them into master and let Travis take over and deploy them to our EC2 instance. However, we already have a couple of things running on the EC2 instance. Yuri, can you pull up the dashboard we built a second ago? What I'm going to do just to demonstrate that this is actually happening, this is actually running, we're going to take a look at actually the example charts that have already plotted on our Google Sites, first of all. Just do it from the Google Sites, the better not stuff. For our team, the better nots. I'm just going to go in and change the data around a little bit, and then within 1 minute, as long as things don't break, we should see that data, not these, because we should see the data change around a little bit.
So can you just walk through and explain what we see, or everybody understands?
Yeah, so this is the output of these sample files that you guys have already seen. And we're going to keep an eye on the one on the bottom because it's easiest to see the change. So what I'm going to do, and actually I think I've got it up right here, I've got a bunch of different cuts of our user base from different years. So what I'm going to do is instead, it's still pointing to, all of our scripts are still pointing toward this user info. I'm just going to call that backup, and I'm instead going to promote user info 2014 to the actual production one just by renaming it. Very simple. So now we've got a whole different data set that's underlying what we've got our R script running on. I don't know how many seconds in the cron runs, but can you actually get it up on the,
Yeah, so let me just pull up some more. So we're sort of skipping over some of the details, so let us show the demo, and then if you care to look under the hood, we'll explain the role of Travis and the role of GitHub in the deployment process. So I'm just going to connect to...
While he's doing that, just to explain one more time, so my little trick of changing out the data set underneath, that's representative of your active changing database that you may end up running this on. So if you've got a transactional database like we are, where we're tracking logins and people making deposits and withdrawals and changing their allocation and creating new accounts, you've got a constant churn in your database. So if you've got a script running on top of that every minute, it's pretty interesting the things you can end up writing on top of that to monitor what's going on. Using nothing but R and a little bit of ODBC with your connection to the MySQL database. Again, we kind of cheated by just subbing out the whole data set for, I think we had all the signups in 2010, and now I just changed it to the signups in 2014.
All right. It's been a minute. Okay. So let us explain what's happening with the system. So if you recall, your local environment was GitHub, checking out code, you're going to run some R script that connects to your MySQL, and you're going to output content to your net accessible S3 bucket. This is a server environment. Do you guys see the difference? You guys see the difference? There's not a whole lot different. You see this little nerd? That's us. He's been replaced by cron. So everything that you've done locally is runnable on the server with a little bit of elbow grease. So let's just...
And that's part of the reason why we were so specific. I don't know which of you folks ran through our setup doc, but there's a lot of like seemingly nitpicky steps where we say, create a symbolic link with this exact name to this directory. That's because that's the exact same configuration that's up on the server. So if you can get the same configuration on your local machine, when you go to deploy your code to the server, you don't have to do a thing. All you have to do is put it out for pull requests, again, the step we skip, and once it gets merged in, Travis takes over, deploys that code to the server, and you're done. There's no changing around production keys, there's no renaming things to work in the new environment. You've set up your local environment to exactly mirror the server environment, and that's one of the reasons why this is so great for people that only know the R piece. If we can set them up with the right framework, all they have to do is code their R and nothing more. It all gets pushed straight.
So the integration environment, we've sort of been describing it over and over again, but there is this guy called Travis. Travis is a continuous build and integration environment. Has anyone heard of Travis in the room? Awesome. Has anyone heard of Jenkins? Okay. Travis is Jenkins' stepson. No, I don't know. But it's effectively the same product. So Jenkins is typically, Alan is looking at me like I'm crazy. It's lighter weight and freer. Exactly. So this is Travis. Travis is awesome for GitHub repository. So if you're hosting your code in GitHub, Travis can pull your projects in, and it can listen for changes to your branches. So it can. How does Travis know what to do? Well, one thing we haven't shown you yet is part of this project is this little. I don't know how to make this bigger. There we go. Okay. So if you notice, everything you need to execute your code is part of your project. The configuration scripts are part of your project, right? The Travis configuration is part of your project. When Travis checks out your code, how does it know what to do? It's just going to read the instructions here. So I'm going to check R out as a Python environment. Why Python? Because Travis doesn't support R yet. It doesn't matter. We're not compiling it. So I'm checking out, I'm telling Travis that I want to run in an R-like environment. I want version 2.7. Travis can install dependencies for Python. You can put a little script in here and install dependencies for R. So Travis can take your code and create a staging environment for you. It can run arbitrary scripts that are part of your project. What is that useful for? What do we want to do in a staging integration environment before we put stuff out into production for a t-shirt? Who wants to answer?
Can you repeat the question?
Testing, right. We want to do some testing. We want to make sure that we can connect to a database, that maybe our actual results match our expectations. We want to do that before we push things into productions. So Travis can do all that. It's a continuous build environment. Travis will yell at you if you break the build. So we've created a little bit of gatekeeping around our production environment to make sure that we're putting out good stuff. And if you work in a team environment and somebody who depends on your data, you know that if your organization doesn't trust your data because you didn't test it before you push it out to production, you have no credibility in the organization. True? Okay. So in this Travis configuration, I basically say only build stuff that is being committed to my master branch. Master branch, that's the version, single version of truth for my code. Once we're ready to roll, all the work that you guys done from your branches, we're going to merge into this single master branch. And Travis is going to pull it out and test it and say, okay, this is good to go. If all your tests pass, Travis has been configured by this after success hook. In that same Travis file, we're going to connect to our EC2 server, and we're going to use Git remote capabilities to tell that EC2 server to check out the latest master code. Okay, so now our code went through Travis, and once Travis gave it a green light, we now have that code updated on our server. So we're almost there. Okay. And this is what Travis looks like. So if John were to commit code to the master branch, you just did it. Okay. Okay. So you can look at your build history in Travis. So if you look at it, all of your commits to the Git repo are represented here. So look, somebody did a pull request. That's me. Or is that you? So somebody updated cron. It's right here. So let's go into this build. Yeah, it looks like it succeeded. So look what it did. It checked out the project. It configured my environment. I have like a contrived little test. I'm just saying check permissions on the files. Make sure that those are correct. You could be doing other validation. Validate that your cron is configured correctly.
Unit tests, integration tests.
Right. In Python, run nose tests or something against your R scripts. This guy can also set up a database environment for you to run your tests. So Travis can get a lot more sophisticated than what we're showing you. But for the most part, you don't need to do a whole lot. So this is the piece that actually pushes code to the server, if you can see that. We executed git push remote into your EC2 box. Git sees that there's new stuff for it to check out, and it's going to execute a custom script that I've added to that EC2 server that basically tells my server what to do with that code once it's received. So that's the final step of your deployment process. That's a little bit of elbow grease that you need to introduce into your production environment. So once you get that code, and I'll show you what the script looks like. Here it is. Here's my post-receive hook. What it's doing is it's saying, if I've just checked out a master branch, then what I want you to do is tell me that I'm deploying that change to the branch. Here it is, deploying changes to master. Right? I want it to say, push this code that I've just received to my whatever, my deployment directory. Updating executable settings. I'm just telling it to execute like a chmod command just so that my scripts are executable. Again, this might be different in your environment, but for me, this is what I need to do. Then again, I'm just doing silly things to prove that it works. I'm just printing out contents of my deployment directory and CI files. And what I'm going to do is run a little bit of magic sauce to detect whether or not my cron has changed. So if you committed a change to the cron file, this script can detect it and reconfigure your cron environment on the EC2 server. Does everybody know what cron is?
Why do you need cron? Why can't you just use continuous integration?
Because I don't want to keep introducing code changes. I want to deploy my script and then put it on a schedule and let that server run my script. I don't need to integrate anything. It's been integrated. I mean, you could, but I think that's
okay, that's fine.
Yeah, you could do it, but I think the round trip time is maybe unnecessary. So here is what my cron script looks like. So again, everything you need to set this up is in this rwiz flowy scaffolding project that we've created. So on the server, cron is configured to execute a daily runner, an hourly runner, a minute runner. Do you want a second runner? I don't know if you can do that, but you can have a weekly runner. You can have you get it, right? So it's defined here. Where is my minute runner defined? It's right here. It's in your project. If you want to schedule your script to run every minute on the server, add your script to this file. Commit it, merge it, get it code reviewed. Travis will deploy it. Your script will run. Unless you broke something, but you get the idea. So we've done all those things. Now, if we go back to Google, don't refresh. Okay, so what am I doing?
I got it.
Got it.
I'll take it from here. So earlier we had this example up, and we were working on our old data set. You remember you saw me go in and change to use the different one? I don't have it up. Here's what this same chart looks like right now. So we have that sample script set, and as Yuriy just saw, it was in there in the cron minute runner. It runs every minute, and since I just changed the underlying data, we now have a different result. So if Yuriy, you go refresh. Scroll down, that awful looking map. I don't know, there's something wrong with the shapefile, sorry about that. So we've got this different look right here now. And again, as I said before, this is all very contrived. I'm majorly changing the underlying data, but in general, you'd write an R script to detect more subtle changes than, you know, every single observation changes in your underlying data.
Yeah, so it's a starting point. Once you get this working, you can do so many more fancier things, right? You could produce sorting tables, right? You could introduce some sort of statistical analysis of your results and maybe alert somebody. You can draw over your chart. So the point is, you've got this foundation, use it until it no longer becomes valuable, and then enhance it as you see fit. If at some point you realize that this is too simplistic for you, and this type of a setup no longer works, well, you've naturally reached a point where this no longer makes sense for you. So invest the money and get something else. Cool? Okay. And so just to wrap up, so that was the integration environment. This should be clear now. Note that Travis is completely optional. This git push to a remote repository that we've demonstrated for you doesn't have to go through Travis. So if you're a single person in a small team, you're the one pumping out bar charts, you can do the deployment to this ECT2 environment from your local machine. Right? Your local machine just needs to have access to that machine, the same way that Travis needs to have access to that machine. So you can cut Travis out of the process, but you better be testing your own code. So that's Travis. I encourage you to check it out. If you have more sophisticated needs, I'd say your next step is to get Jenkins installed locally. So this is what we use in our environment. I think Alan will vouch for that. But we've got Jenkins running. We build all our codes and we run all our tests. And if things break, Jenkins will yell at us, Alan will yell at us. Stuff doesn't go into production until Jenkins gives us a thumbs up. This automated deployment process is what we do internally for most of our projects, but we're gaining ground. So again, your server environment looks exactly like your local environment, and there you have it.
Okay, we got to find a way to get out some shirts. Raise your hands. What service do we use to store our outputs?
S3.
S3. Come up first. Yeah, come on up. What side? Ask a question.
Okay, what is the role of an integration server? What is the role of Travis in the environment? Awesome. Why do we want to automate deployment? Why do we want to automate as much as possible?
Because doing things manually sucks.
Doing things manually sucks. Fantastic. A little bit more color.
Get into that.
Come on up. Yes. You can ask me a question? Do I get a shirt if I answer it? Yeah. Have we tried using RPubs? Can you explain to people what it is?
No, the same thing, publishing on the web. Yeah, it's public, but if we just want to publish, we can also create our own team.
RPubs is a service offered by RStudio, and it's static.
Then you use Shiny, you can change the line.
So again, you can take any layer of this process and swap in whatever you feel more comfortable with. Less security, more R, less R. This works for us. So I'm telling you what I'm doing.
RPubs is both not secure enough and not flexible enough for us.
Okay, how much does it cost to get up and running on the Amazon cloud?
Who said it? You want a shirt?
Yeah.
What size?
Big.
Big.
So what? Yeah, so anyway, do you guys have any questions for us?
Give me one.
There's been some side conversations. Any questions?
One.
Okay, let's break. If you guys have any questions, we'll be up here to talk. Please mingle, do whatever. Thank you so much for coming. We really enjoyed it.